Now we'll be talking about tangents and differentiation. So what's a tangent? A tangent is a line that passes through only one point on a curve, right? So if you think about it, the gradient of the tangent, the slope of the tangent, is the same as the gradient of the curve at that certain point, right? Because the curve has many gradients. It has different slopes. It can turn this way, and as it turns here, it becomes like this. But a tangent has a gradient which is equal to the gradient of the curve at one point. That's what a tangent is. So I'll demonstrate here. Here we have a curved function, right? And the gradient at that point, this point, I'll call it Q, is equal to the gradient of the tangent passing through Q. Let's say I have another point, P, okay, on the same curve, but I have another tangent. And as you can see, the gradients of this line and this line are quite different. One is negative, one is positive. So even though it's on the same curved equation, the gradient of the tangents at different points are different, right? So now we'll see how this relates to differentiation. So the general form is y equals something something x squared or x cubed or whatever. This is your curved equation, right? So this is okay. So if you differentiate this equation, dy dx, you get the gradient function, all right? For example, I had this equation, y equals x squared plus 2x plus 5. This is my curved equation, right? It's a curved line. If I differentiate this, I get 2x plus 2. And as you can see, it's not a number, it's not a value, it's a function. So this is my gradient function. So the entire curve, this entire curve, has this function, 2x plus 2 as a gradient. So no matter where I pick, the gradient function is still 2x plus 2. At Q, the function of the gradient is 2x plus 2. At P, it's 2x plus 2, right? The thing is, the reason why it has different gradients at different places is because the x values change, right? So to find the specific gradient, an actual number, you have to sub in the value of x at a specific point. So when I say dy dx when x equals to n or a certain number, if I sub it in, I get a gradient, an actual number, m. For example, this was my gradient function, 2x plus 2, differentiated from here. And if I say at point Q, now let's say my point Q is 1, 8, right? So if my point Q was 1, 8, and I sub in the x value 1 into here, I get 2, 1, 2, and I get 4. So the gradient of the tangent at Q is 4, even though the gradient function was a function. See, so that's the difference. A gradient function describes generally, no matter where you are on the curve, the gradient of any tangent. The specific gradient is when you sub in the values of x at that specific point. So for example, here Q, I subbed it in, and I get gradient there is 4. So that's the difference between these and these. Next, we have the equation of a tangent. So the gradient here only describes the gradient of a tangent, right? Only the slope of the line, the straight line. But I didn't write the entire equation for the straight line, right? So to do that, you just take the m you had from just now and then put it into the y equals mx plus c form. You might be thinking, how do I find c? Well, since you have 3 knowns and 1 unknown, you can just sub them in to find c. For example, at Q just now, the same point, I know that the coordinates were 1 and 8. So the values of y were 8, values of x are 1, and m just now I found was 4. I sub it in, and I found that c equals to 4. And if I rewrite the whole line equation, I get y equals 4x plus 4. So this is the equation of a tangent, right? So you should have this all in your head by now. This is a curved line equation. This is the differentiated curved line equation, which is equal to the gradient function. And if you sub in the values of x at a certain point, you get the gradient, a number. And if you use this and sub in the values of x and y at a certain point into the y equals mx plus c form, you get a straight line equation, which is the equation for tangent, right? So this is all about tangents and differentiation.